Good evening, everyone. Thank you so much for coming out tonight on this beautiful July evening to talk about Hamilton's water. I'd like to thank, we've got quite a few committee members here tonight, and thank you very much for coming out, which includes David Smith, David Thompson, Bill Bowler, Bob Woodbury, Jack Lawrence, Peter Clark, Wayne Castaway, Wayne, David Wanger, Virginia Cookson, Richard Boroff, and Mary Lester. So thank you all for coming. The goal of tonight's meeting is just to share information about Hamilton's water, from its sources to its treatment to its distribution. Obviously, what happens with Hamilton water has a lot to do with the future growth of Hamilton and where we can are able to grow in the future. What I'd like to say first of all is that, and be clear about, is that the water in our town meets all state and federal standards for safe drinking water. We want that to be clear. But in order for this to remain the case for the future, we're going to have to make some pretty serious decisions over the next few years to keep it in that way. We're going to break down tonight into two pieces. One is about the water source and as digging in deep into as much we can about what our current source is, what any other potential sources may be that we could take a look at. And then the second part is going to be more about the water treatment plant and the distribution system. So it's kind of the source and then the kind of the operating side of things. I want to, so we've got quite a few people here tonight helping out, and thank you for that. But we're going to start off with a presentation, like I said, about our water sources, and that's going to be led by our DPW Director, Tim Olson, and our engineering consultant, Peter Calarazero, and our special legal counsel for the water, which is Ray Myers. The second presentation, like I said, will be about the distribution of the water, including the water treatment plant and the distribution. And that'll include Tim Olson again, Peter again, and our water superintendent, Dave Dolan. So why don't we get started? Tim, if you want to take the lead on our Wayne,
should we start with Ray? Are we going to do
Ray, want to start off?
Sure.
You want to do the Pledge of Allegiance? Jeff?
Oh yeah, why don't we do that first? Thank you. Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thanks. So yeah, Ray, if you wanna, would you like to begin?
Sure.
Okay.
Good evening. My name is Ray Miyares. I am with Miyares and Harrington and have been attempting to assist the town in its water permitting matters since 2006. So I'm an old war horse on this issue. Tonight I hope to condense down that 14 years of work into about 10 minutes. As many of you know, the Commonwealth is broken up into various river basins, and most of Hamilton and all of its water supply wells are in the Ipswich River Basin, and most of them are in the Idlewild Brook sub-basin. We operate under a permit that was issued by the Department of Environmental Protection pursuant to the Water Management Act. And that permit specifies the total amount of water that we are entitled to withdraw from all of our wells put together, and imposes a number of conditions. Many of those conditions are operational or procedural, but some of them have actual numbers that we can compare our performance against, and those are the ones we're going to focus on here. So there is a limit on the withdrawals per capita in residential use, the limits on the amount of unaccounted for water that we can have, and there's a limit on the summer withdrawals that can be made. And we'll talk about each of those in due turn. So if we can move on to the next slide, please. Okay, so back in the 1980s, when the Water Management Act was originally enacted, every town was invited to register the amount of water that they were using from their wells at the time. And the town of Hamilton submitted documentation showing that at the relevant 5 years, from 1983 to 1987, the town was averaging withdrawals of 920,000 or 0.92 million gallons per day. The purpose of registering that with the DEP was so that that amount of withdrawal would be grandfathered from regulations. So that is supposed to be it's supposed to be understood that the town could continue to exercise its rights to withdraw the 920,000 gallons a day without interference from the department. At the time, the department's policy was to encourage towns to ask for a permit on top of that so they could secure additional water beyond what they were withdrawing in the 1980s to accommodate future growth. And so the original permit that Hamilton got was for water that it didn't really need. But it allowed water to be held in reserve so that it could accommodate future growth. And the original permit stepped it up so that every 5 years, more water would be allowed under its permit. Back around 2000, DEP changed its mind about that and decided that it didn't really like giving out those permits, and they started to ratchet back. And one of the things that DEP did was to I don't want to say strong arm, let's say strongly encourage the town of Hamilton to share some of its permitted volume with the town of Wenham. And Joe, if you show that, yes. So ultimately today, what we have is an additional 110,000 gallons in our permit. There is no longer provisions for that number to go up in the future, and the permit always used to have a higher number than that, but that's the number that we have today. And so the total, what they call the authorized volume, is 1,030,000 gallons per day. And that is what our permit says. Our permit is up for renewal, and we'll talk about that later on in the presentation. So, next slide, please. This is the good news slide. If you look at the amount of water that Hamilton has been withdrawing for the last 10 years or so, you can see that we are actually staying well below not just our permitted volume, but well below our registered volume. So we are using far less water than what our permit currently allows. If you look at the graph on the left, and you look at the four highest rainfall years in this period are 2008, 2009, 2011, 2013. You can see that there's a little bit of correlation not great, but a little bit of correlation with low withdrawals. That is, when there's a lot of rain, there's less water being withdrawn. If you look at the other end of the spectrum, the two lowest rainfall years were 2015 and 2016. 2015 is a high withdrawal, which you'd expect in a time when rainfall was low. 2016 is a bit of a special case because that's the year when the Executive Office of Environmental Affairs declared a series of drought conditions, and the Board of Selectmen at the time declared a state of water conservation, so that the water bans that were imposed that year were somewhat more stringent than we have had in other years, and that maybe accounts for the fact that the 2016 withdrawal is low, even though the rainfall was also low. In our permit and in every permit across the Commonwealth, there is a condition that says, that uses a fancy term, RGPCD, residential water, RG,
Or gallons per.
residential gallons per capita day. What that means is how much does each person use in gallons per day per person. The standard is 65, and as you can see on the right, with one exception, we've been well below every year. In 2008, came close to hitting that 65 number. 2012 is a special year because there seems to have been a little bit of a spike there, and there's a possible explanation for that, in that we have a high level of what's called unaccounted for water. So if you look at the next slide, we have in our permit, and many permits have the same provision that says that you need to be able, your water supply system needs to be able to account for at least 90% of all the water that it withdraws. So what that means is that it ought to appear in somebody's meter somewhere that the water that came out of the ground actually went to a customer. And only 10% can be unaccounted for. And generally, unaccounted for water involves things like leaks in the system, where the water is leaking out of a pipe somewhere, or other kinds of special things that may have happened. And as you can see, in 2012, we had quite a spike in unaccounted for water, which may account for the high water usage in that year, or higher than normal water usage in that year. The unaccounted for water is a persistent problem in many towns, and as you can see, the cap in our permit says 10%, and in the last 10 years, we've made that 10% exactly once. The water department, I'm sure, is quite vigilant in looking for ways to account for the water that it withdraws, and we've gotten better in the last couple of years at getting close to the cap. There are probably additional things, and I'm sure we'll hear about what can be done there. You note that the one year where we actually hit the 10% was the 2016, the drought year. So that was the year when I think the greatest scrutiny on the water system was made, and it gives reason to believe that over the next few years we will be able to bring ourselves into compliance with the 10% cap. Next slide. The limit on summer withdrawals, however, I don't know that we can be that confident about. The reason that the Board of Selectmen way back in 2006 started to have problems with the DEP permit was exactly this, that DEP introduced a permit condition for the first time at that time, which limited the amount of water that could be withdrawn during the summer months, defined as May through September, to 104 million gallons total. And back in 2006, the Board of Selectmen said, you know what, we can't feel confident that we're going to be able to meet that. We don't really have good tools for meeting that. We don't necessarily know that we are on a bad path until it's probably too late to do anything about it, and it's pretty hard to predict what years will have a problem with the limitations on the summer withdrawals. So, for example, in 2008, which is one of the years that there was a violation, that was a high rainfall year. 2015 was a low rainfall year. The other 3 years were sort of in between, moderate rainfall years. So it doesn't appear that the problem is related necessarily to how much rain we're getting, but it seems to be something that is intractable and difficult to predict. Now, we actually did super great in 2018, and I'd like to congratulate Tim for that, but I'm not sure Tim knows why it turned out so good. So therein is an issue. Many communities have resisted the imposition of a summer cap. The litigation that we were involved in back in 2006 directly challenged the DEP's right to impose the summer cap, alleging that it was an interference with our registered rights, since we can't withdraw the full amount of our registered volume if we are not allowed to withdraw water when we actually need it. DEP's response was we could build a large reservoir, and then we could withdraw it in the winter and use it when we needed it in the summer. But that we didn't think that was terribly persuasive. You may recall that that case resulted in a remand of DEP's decision back to the department. And by the time it got back to the department, DEP had already issued its next permit, so it sort of died there as unresolved. If you look at the next slide, you see that this is a depiction of the months in each year where the highest withdrawals take place, and as you can see, they're all in the summer, in May through August, but surprisingly, August, which is typically the driest month, is not actually where our withdrawals are the highest. We actually, many years, the withdrawals in July are in fact higher. But the key thing is that if our summer withdrawal is going to peak, and it's going to peak in July, you're already halfway through the period when you might otherwise be able to do something about your total summer withdrawals. Now, the key thing that we have going for us or against us is the so-called water bans. I'm sure you're familiar with the fact that that every summer the DPW imposes a restriction on the use of outside watering this is actually something else that's required by our permit. It's not something that we do because we think it's necessarily going to result in better compliance with our permit, but it's something that DEP does indeed require. The way our permit is written, you have to start the water ban when the flow in the Ipswich River reaches a certain level at the Ipswich gauge. When it falls below a certain level, that's when you have to start the water ban. And then if there's 7 days in a row when the gauge shows above that level, then you can take it off. When we first started doing water bans, we would put them on and take them off and put them on and take them off, and it was very confusing, and nobody thought it was a good idea, and essentially became unenforceable because nobody knew from 1 week to the next whether the water ban was on or water ban was off. So in more recent times, I think the idea has been to impose the water ban when the Ipswich River gauge goes down, and then just leave it on for the rest of the summer. And so I think that's what we've done. Some years ago, the town engaged a hydrological consultant to advise the town about how the Idlewild Brook behaves in the summer. All but one of our wells is in the Idlewild Brook subbasin, and so how it behaves in the summer is important. And what the hydrogeologist said was whether or not we take any water out of the Idlewild Brook subbasin, the fact is that in the summer the water flows into the Wenham Swamp and never gets to the Ipswich River, even if we were not to withdraw any water at all. So we don't see a whole lot of difference between the way the subbasin behaves, whether or not we withdraw water or we don't withdraw water. It's either way, no water is going to flow into the Ipswich River. Okay, so the next slide. DEP likes to engage in some legal fictions, we'll call them. So what they did recently, when they overhauled their regulatory structure, they created something called a baseline flow. The baseline flow in Hamilton is equal to our registered volume, so 920,000. And they announced that when they do their next round of permitting, which is underway now, they're going to treat any application for renewal that goes above the baseline flow as if we were asking for an increase. So notwithstanding the fact that our current permit calls for 1,030,000 gallons per day of an authorized volume, if we ask for more than 920,000, it will cause DEP to treat that as an increase. And so DEP has made it very well known that what it really in its heart of hearts wants us to do is to give up that 110,000. So that's what DEP thinks that we should do. At that point, we've got a permit that doesn't authorize any withdrawal of water at all beyond what's registered, but it does allow us to operate the Bradshaw well, which is not covered under our original registration because it didn't exist at that time. So that's the option that that DEP, I think, is headed for. The alternative, in the next slide, is that we go ahead and say we want to increase. We want to keep the 110,000. Now, remember, we're not using it, but if we want to keep it anyway, in case we decide we want to use it at some time in the future, DEP is likely to impose a whole host of new conditions on our permit. The two principal ones are that we're going to would have to demonstrate that we have looked at all the alternatives that might possibly be available to the town, and concluded that this 110,000 that's in our existing permit is the best alternative. And then the other thing we would have to demonstrate is that we have taken appropriate steps to minimize the impact of that withdrawal. So they've made the barrier to keeping our existing permit volume reasonably high, and that's something that the board is going to have to make a decision about at some time in the next few months as we get into the serious nitty-gritty of permitting. So that, in a nutshell, is the permit situation that we have today. And I understand you want me to defer questions until the other two have had their presentation. Okay. So thank you very much.
Thank you very much.
All right, Tim Olson, DPW Director. Thanks for coming tonight. I brought Peter Calderazzo with me as well to answer any very technical questions. He has provided this nice slideshow to go through some of the kind of past, present, and future of the Hamilton water. Appreciate Ray going through the legal aspects, and then we're going to kind of handle more of the operational key pieces of the sources, distribution system, treatment. We're going to go through pretty quick. Happy to answer questions after. I came here in December of 2016. Hamilton, I know a lot of people have been here a lot longer than I have, but the system is an age system. We've been doing over the last probably 7 to 9 years significant distribution upgrades. We've replaced, I think, close to 50,000 feet of new water main. We followed that up with a pretty large upgrade to the water treatment facility. What we did there was we brought back the original design of the treatment plant that was designed for optimizing the removal of iron and manganese, and we've done that work. It's been very successful. And now we are working, to improve the quality and the chemistry of the water. And I can say, and Peter will get into a little bit more detail, that the water that we have currently today has been far exceeds the water in the past. And a lot of not only the water quality, but the operational issues at the plant that our operators were facing with a plant that was running at about 50% efficiency. Now we've returned it back to the operating design flows. The maintenance is far less. The operation of the plant is much more manageable. So the projects that we've done in the recent past have greatly improved the existing system in Hamilton. So I'll turn it over to Peter.
Okay, thank you, Tim. Hello, good evening. My name is Peter Calderazzo, and I'm with OBrien Engineers. I've been working with Tim and the treatment staff for the last 2.5 years to address some of the operation issues that Tim had mentioned.
You need to talk in the mic.
Oh, I'm sorry. Can you hear me now? Okay. So I'll basically go over, keep it short so we can leave time for questions. I know that's probably on everybody's mind. So we'll touch a little bit on what Ray had mentioned, and we'll get into some of the operational issues. But so this is the source part, just a continuation of what Ray had started. So as Ray mentioned, the town of Hamilton has 2 groundwater supplies. One is the Idlewood well field, which currently has 5 active wells, and those are the wells. I won't read every one, but there's 5 in there that currently are used at the plant. And then there's the School Street well, which is located in a different part of town. Both are located in the Ipswich River Basin. Enjoy the next slide. It's just an overview of the water system that kind of shows where the wells are located in relation to each other. So the Idlewood well field's on the left side, and the School Street is not too far from here, actually.
Let me point you out. Yep. So,
Okay.
so the well field is over in this area, Pleasant
Yep.
Pond area, downtown. Yep. And the School Street well is actually almost right across the street
Yep.
from where we are. And our tank is at
Right there.
up here.
Yep.
Browns Hill, up on the Gordon Seminary.
So just an okay, and this is a table, just some information on the wells, just gives when the well was constructed, how deep the well is, some physical characteristics of the well, and some of the approved safe yield that Ray had touched on a little bit, and some of the pumping capacities of the well. As Ray said, the permanent withdrawal of the well system itself is 1.03. The Idlewood well field is 0.88, and then the School Street provides 0.19, which gives you the 1.03. So, next slide. So, yeah, as I just said before, so just a little bit on what Ray had said. So the Idlewood wells have an approved safe yield of, can't read that, 0.88. The current production rate of the well field is about 1.3, so they could actually pump up to 1.3. So that provides some flexibility in how the wells are operated. It gives the operators a chance to kind of let some of the wells kind of relax a little bit. And we just, as Tim mentioned, we just completed some recent upgrades to the treatment plant, and just an overview of what we really did. We'll get into that a little bit more in the operations part. But so right now the plant currently pre-oxidizes with sodium hypochlorite, removes iron and manganese through the 4 Filtronic pressure filters. We post-filter disinfect with sodium hypochlorite. They also fluoridate with sodium fluoride, and they provide corrosion control with a polyorthofossil blend. Just something to note, and as working through on the system the last couple of years and going through some of the issues, Idlewood well number 2 is one of the, in terms of water quality, has the worst water quality in the well field. Has elevated levels of manganese and total organic carbons, as well as color. And that well has been offline actually since November 2018, which we'll touch on a little bit, some of the issues we had in the water system. Next slide, John. Okay. As I said before, the School Street well has an approved safe yield of 0.19 mgd. The current production rate of the well is about 0.16. So the well right now pumps below the approved yield, so we never really get close to the yield, as Ray had mentioned. The School Street well is a pretty good well source, doesn't really require any other treatment besides chemical. And right now the well station is treated with potassium hydroxide for pH adjustment, disinfection with sodium hypochlorite, fluoridation with sodium fluoride, and corrosion control with the same chemical that's used at the Idlewood plant. As I said, School Street has very, very good water quality, very low iron, manganese, and TOCs. Unfortunately, it doesn't provide as much volume as the Idlewood well field, but it is a good source. And this is just this is an excerpt from the draft water system master plan that we just issued to the Board of Selectmen for review. So this table just kind of shows you the average daily water usage since 2013. And as Ray had showed in one of his slides, over the last 10 years or so, the town really has not been able, didn't have to pump the whole permit. They've been under the authorized withdrawal for the last 10 years, and this is just a snapshot of the last 4 years. So the permanent withdrawal was 1.03, and the last 5 years or so, the town's used on average about 0.6 mgd. So there's always been a surplus in the permit to pull from, which is good. And as part of the draft water master plan, we looked at, is the well field going to be sustainable and able to meet the future projections of the town? So, again, these are tables taken from the master plan. So, we estimated future water demands up to the year 2035. We looked at past water usage trends, population projections from some of the agencies in the state, as well as the U.S. Census, and trends of the town itself. And so from that information, we came up with a population projection increase by 3% to the year 2035. Both of the MISER and the MAPC, which are agencies that look at population projections, both of them have projected a 4 to 6% decline in the population. But that doesn't really account for any available land that may be there for growth and development. There's some future developments that are planned right now. And just for future planning, it's really good to, you want to have a conservative estimate for planning. So to provide that estimate to allow for some future growth, because there is available land for growth, we projected a 3% increase in population. So you can see from the table on the left, Right now, there's a population of 8291, so by 2035, we're projecting a population of 8540, which is not a huge increase, but it kind of falls in line with what's been projected by the other agencies. And the table to the right kind of shows how that affects the water usage. So in 2017, right, the average day demand was 0.57 million gallons a day with a maximum day of 0.771. That's the high demand that Ray had shown in July. And by 2035, we're going to have an average day demand of 0.671 and a projected max demand of just over 1 MGD. Next slide, Joe, thanks. So based on the permitted withdrawal that you have and the pumping capacity of the wells that you have, right now the well supplies are adequate to meet what we project up to the year 2035. So as you can see, the current production rate of all the wells is 1.47 MGD, and that exceeds the future supply needs. But of course, that's assuming that the wells are continually running as they are now. Obviously, over the years, the wells have lost some of their production capacity because of the water quality, and they require pretty frequent maintenance. And I think over the years, there's been a couple of satellite wells put in to offset the loss of some of the original wells. So, I mean, things look good on paper, but again, that's assuming that everything stays as it is, which is probably not going to be the case. So that's why we're looking to other alternative sources of supply that could possibly help to augment any loss that you might have from the wells. So as we said before, Idaho number 2 is the one that we're concerned about because that has the highest levels of TOCs in color. It is one of the older wells that were put in. It's been offline since November 2018. And because of the water quality issues that we're going to talk about later on, there's a concern that the use of that well, it could be limited at least, or it could be discontinued, depending on how we proceed with addressing the water quality issues. So if we did lose that well, we would lose a production capacity of about 0.32 million gallons per day, which overall was still enough to meet the demands, but it's going to be tough to meet the demands and during the high demand periods, and it's going to put some strain on the well. So losing that well could be an issue. We need to kind of address that. So as Ray had said, we're looking at other potential sources of additional supply. Here's just 3 examples of what we're looking at. So we were looking at for maybe possibly putting in a new well within the North Coastal Basin. We did some initial testing at the Ford property. Didn't look very promising, so we kind of stopped that. But there's some other sites that we may want to investigate. So we'll talk about that. We looked at maybe an interconnection with the Manchester, possibly, as well as an interconnection with Salem Beverly to try to pull some supply to augment any loss in wells, and maybe just to provide a source of emergency backup as well. So those are all being looked at now as part of the master plan. So once we finalize that, that'll be submitted to the selectmen, and we can discuss that at that point when we know what direction we're going to head in.
Where is the North Coastal Basin?
That's a good question. We'll get that in a second. Just hold that thought. So, and so in addition to looking at other sources, we were also looking at maybe evaluating what we can do to optimize the use of the Idawood wells, because right now, if we made an investment into the plant, the plant's running well. Obviously, there's some issues that we need to address in the future. So with the money we already spent in the well and the fact that the sources are there, it may make sense to try to maximize that use before we look at other sources, other sites, because that's going to be more expensive, and obviously it's going to be an issue in terms of funding. So some of the things we're looking at to maximize the plant use and the well field use is to add a TOC pretreatment system at the plant to help address some of the water quality issues that have been ongoing. Also adding a THM aeration removal system in the Clear well to help further that along. And also looking at putting in a new satellite well to replace the Idawood well number 2. The hope is that we could drill a well 1,500 feet away from the existing well and find a spot that would provide the water with some better water quality to allow that well field to continue to meet the demands moving forward. So I understand we're going to take some questions and answers on the water source first before we get into...
So welcome, everybody. I'll be the last to welcome us, and I'm not going to talk anywhere near as long as these gentlemen did. I'm Joe Dumbelovitz, I'm the town manager here. This is their meeting, and we want your questions, but to make sure that everybody listening here and at home on the cablecast when it gets broadcast later can hear your questions and their answers, we ask you to go to the podium to ask the questions. All right? So we'll open it up to questions on the water source aspect. Once we close out, we want maybe 15 or 20 minutes, Jeff, of
Sure.
questions. And then will go on to the water system, what we do to treat the water and distribute it to the town. So if anybody has questions, by all means, head up to the podium. Thanks.
I'm just wondering what the, do you want introductions of who we are? Or
Yes,
anything?
your name and, yeah, you addressed it.
Jack
Thanks,
Lawrence,
Jack.
105 Rock Maple. I'm just curious, I was talking at one point some years ago about the reason the Idlewood well was not functioning as it should, or was polluted or whatever, not polluted, but was not operating as it should, was because of crack in the casing. And I think there was an attempt to do some maintenance at the time. Where you talked about another satellite well being dug nearby, is that an effort to get the same production as we used to get from that well, from a slightly different location? Was that what it was all about, or what is the situation?
Tim Olson, Director of Public Works. I'm not sure about the crack casing, but the attempt, if we do want to go forward with looking at an Idlewood 2 satellite well, would be to drill fairly close to that well to obviously optimize the amount of withdrawal, but hopefully with a much more better quality source. Does that answer? So we would take Idlewood 2 offline with the.
Well, the generators, is it just because it's silting up, or?
It's not so much the generator that the water quality is somewhat poor compared to the rest of the wells, and it's actually contributing to some of the issues we had with the water quality. And to use that further, continue to use that well like they did in the past, we could have some issues in terms of the water quality regulation. So we're looking at ways to address that in the future. One way is to, instead of using that well, put a satellite well, which is, we've done that, they've done that before in the past. They have Idlewood number 1 satellite and Caisson number 1 satellite. So over time, the original wells will get, because of the iron and manganese, the screens get clogged up, they lose production capacity and the water quality suffers. So after so many years, you can put in what they call a satellite well to replace that. The permitting is a little bit easier to go through as far as a new source and a new site. So we just try to manage the well field as best we can. So that allows the well field to continue to produce the water that we need to meet the system needs, and also provide a water quality that's easy to treat. Idlewood number 2, when they use it in the past, they really puts a strain on the treatment system too, because the water quality is so bad that you notice the color of the water coming out isn't really not to what the standards that we want to have. So right now we made the decision not to use it unless we really have to. Right now we've been, the operators at the plant have been doing a good job at managing what they have, so they'll be able to keep that well offline, which is helping us meet the standards right now. So.
Great, thanks, Peter. Yes, David.
Good evening. David Wanger, 5 Boardman Lane. Thank you all for the presentation. Ray, I have a question for you. You mentioned the DEP had some condition regarding sharing with Wenham, but you didn't go into that at all. And so my question is, what is that, and what is the current status of it?
So I believe the time frame we're talking about here is the early 2000s. Prior to that time, instead of having 110,000 gallons per day in our permit, we had double that, 220. And DEP prevailed upon the town, and this is even before my time, so I'm only telling you what I gleaned. Prevailed upon the town to give up half, so cut it from 220 to 110, so that Wenham could increase their permit by that same amount, 110. And I guess in light of the fact that we weren't using it anyway, and we wanted to be a good neighbor to our neighboring town, that's what happened. Now, it is my understanding that Wenham is in fact giving up its permit entirely. They already have completed that process, so that volume is lost. We don't have it, and they don't have it either.
It does not return to us.
Did not return to us.
Thank you. Another question, Ray, you had mentioned the unaccounted for usage,
Yes.
unaccounted for phenomenon, and that we exceeded the 10%.
Yes.
Why is that?
Well, it's probably a variety of reasons. You want to say?
So when we look at the water, we look at, when I'm preparing an annual statistics report at the end of the year, I look at the water from the plant, coming from the finished meter of the plant, compared to what our meters capture in the system, and compare those two numbers. There's also a variety of other municipal uses. If it's fire training, if it's we have flushing system like hydrant flushing. So there's a variety of other uses of that water, that difference that we as part of our operations. Part of that is also if there's any type of water, I call them situations. I don't use the break word much, and we try to estimate if we do have those situations in the system. We try to estimate how long have leaked, as well as the estimate on how long it took us to fix and how much water's lost. So those factors come into that kind of difference between finished meter and meters in the system. You take out all those municipal uses and the estimates for water loss to situations, flushing, municipal use, and then there's a percentage left after all of that and that is the unaccounted water. It could be higher because there might have been a low estimate on water loss to situations. That's a lot of, it's hard to kind of quantify that because we have no idea how long water is. There could be minor leaks in the system that aren't showing up in our numbers. They're not showing up at the plant. We're not getting any, the system is a large system. We've got 54 miles of pipeline. That small leaks won't surface, and we wouldn't even see that, but it is some water lost. So I do the best I can to estimate those, leak life, I call it, but there is a percentage that it is an estimate. So there could have been some additional leaks and water loss to leaks.
Does it suggest potential abuse by users?
Clarify the question, David, is abuse in what terms? Because anybody has water going through their meter.
Avoidance of the meter.
Do you have any evidence of
No evidence.
We don't have any evidence of that since my time here. I haven't gotten any word that there is anybody that is abusing the water and not paying for it and having it metered.
Thank you. And Tim, I have one final question for you. Darcy and Nick, you'll remember this. During the reign of Joe's predecessor, FinCom was called upon to spend money for, I thought, a filtration.
Green sand.
Thank you, Darcy, green sand. And then I at least lost track of the usage of that. Could you just quickly tell us whether that expenditure was fulfilled by actual usage?
Are you referring to the new media that we?
The old media, I think.
This was, again, prior to Joe's coming.
The green sand.
Yep.
The one that
New media.
The new media that we,
didn't work.
So we are making use of that.
So if I understand you correctly, we came before FinCom to purchase new media.
Correct.
For the treatment plant.
Yes.
And that media has been installed.
Okay. Thank you.
Yeah, that's what we currently have in our filters right now.
Great. Thank you.
Yep.
Duke Seaver, Essex Street. Nobody mentioned the Bridge Street well. That's dead?
It is inactive.
Okay. Sometimes when you draw water to water the football field in the fall, we get a tint of brown water. Can't you put a pump and something in the Miles River and water from the river and not affect the rest of the neighborhood?
That's more of an environmental question. I wouldn't know if that's possible or not. But I think what we have come so far, I think we haven't had too many discoloration calls. So I'm hoping that the ability to flush annually and biannually.
Well, I wasn't talking flushing, I was talking water in the football field.
Right, but you're telling me that you had discoloration
Yeah.
while that happens. So I'm not sure if that's possible or not. I think that's more of a Concom environmental question. Sure.
Okay, so the answer is you don't know whether you could take water out of the river or not to do the field.
Not at this time.
Thank you.
Hi, Walter Lozinski, 10 Honeysuckle Road. To my knowledge, there were 3 studies done in the 80s. At that time, they said there were only 3 locations where real water could be drawn. I see 2 of them. What happened to the 3rd one? I do know what happened, but I'm curious, the official.
What's the third one?
Patton Well.
Patton Well? That was prior to me
I know.
starting here.
I
So
know.
if anybody has any comments on Patton.
I'll make a comment.
Sure.
Okay.
That was a large supply of water. Former Board of Selectmen, former town manager, accepted land from the Patton estate, said, we can get some tax revenue. So they built the road and put the houses in, which was closer than 400 feet. So you had to pour concrete down the well. The former town manager said it needed treatment and they couldn't treat it there. Well, we had $5 million for new pipe. A new pipe could have been run all the way to the main station and back to feed. I don't know why that was done except for money, to balance the budget. You're going to look for water, but you're not going to find it. If you look at those 3 reports, you're going to see that those companies, reputable companies, said there wasn't anything.
Thanks, Walter.
I just had one other question. Back, we had a very diligent leak detection program back in the 90s, and we found that, in fact, many of the houses in town were not being properly metered, that they were working on estimates. Are we still on estimates in any houses, or do we now have working meters in every location that should be metered?
I think so. I believe 99% are metered. 99.9 probably. Just the one.
Hi, Judy Blaine from Norris Road, Hamilton. I was just wondering, because I don't know the answer to the question, how people with private wells impact the water, because they're not metered, and I assume that the water comes from the same water tables as our town wells, and so I just, how does one keep track of that part of it?
That's a good question.
Well, the sad and bitter truth is we don't. In addition to the municipal wells that are regulated under the Water Management Act, the only other water withdrawals that get the attention of the state are from myopia, because they have a registration that allows them to withdraw in excess of 100,000 gallons a day, just separate and distinct. But you're absolutely right. All of the water is coming from groundwater, and it's the same groundwater whether it's being pumped by the town or being pumped by a private individual. But nobody is attempting to measure that at the present time.
Okay. And my second question, and this may not have any bearing on what we're talking about, but there was a discussion about having a marijuana factory down by the Patton's property, and there was a hue and a cry about how much water this would take, and it would take away from the water we have, and I don't know if you were involved in any of those conversations, but I kind of watched it from a distance and thought it was interesting. Whether it's true or not, it's just a bunch of citizens chatting back and forth, but...
So my understanding is that the amount of water that they were looking for was on the order of 7,000 gallons per day, a number that is so small it wouldn't show up on any of our graphs.
Okay.
So it's a big number considering it's one user, but in the grand scheme of things for the whole town, it probably wouldn't even show up as a blip on those graphs.
All right, great. Thank you very much.
Thank you.
Hi, great presentation. Thanks for your time. Bradshaw up on Bridge Street. Kind of wondering two questions. One is there seems to be a summer limit on withdrawals that we seem to be hitting or exceeding. And if you look at growth in the future, I haven't seen any discussion about how to address that other than putting in a big storage tank somewhere or fighting the EPA or DEP with a legal battle. So I'm interested in that. That seems to be like a good portion of the year. And the other is there a replenish rate for our wells? In other words, do we know if we're exceeding or not the replenish rate of our wells, or does that term even mean anything?
Well, shall I
Well, in terms of the wells, yes. I mean, the way they operate the wells is a drawdown. When they stop the wells, it recovers, or when you said replenish. So the way the wells operate, they manage them so they recover within the time frame that they're in service for the next round that they need to be used. So that's all part of how they operate and manage the system.
Does that take weeks or months to, is it a ground?
No, they run a well, they turn it off, and then the operators will make an assessment, and they turn the well on. If the drawdown is within the limits,
Okay.
they use it until the drawdown gets to a
Yep.
point where they know they're over pumping the well and they stop. And the recovery's pretty quick. I mean, it's days, it's not months or weeks.
Right. So we're sort of at that replenish rate, maybe, or near it.
Yes, what they pump the wells at is what the wells can be pumped at and recover in the suitable time to be ready for service. So
Interesting.
they're not over pumping, which
You're
is
right,
why having
right,
more wells in
right.
a well field is good to manage
Right.
Yeah.
Right.
each well.
Yeah, I think that needs to be said, that they're not maxing out the wells.
Right.
They're running the wells at a time that it's not too detrimental to them. They're able to recover. They're able to keep up,
Yep.
blend it all together. We're meeting demand, but we're not maximizing the pumpage.
Yep.
So
And
as far as
the
the
growth issue in the town, I mean, I live near where they were going to put 65 new units, and some people were wondering about the draw on water. So what about that question about the summertime usage and
Well,
growth?
The first thing you have to understand is that summer cap number that DEP imposed on the town was literally drawn out of a hat. It has no actual scientific basis. It's just a number they picked. And they picked the number by taking Hamilton's historical usage in those summer months and comparing it to the historical usage in the rest of the year, and they decided that the average for those months was sufficiently more that it should be cut down by a percentage, and so they just drew a line, said cut it to this, and the selectmen at the time objected because they said it doesn't have any actual scientific basis and it's interfering with our ability to use our water under our registration, and anyhow we can't meet it. All of those things have turned out to be true, but I don't know that there is any. Tim is a great manager, but I think this might be a problem that's even he can't solve. How to meet the summer cap consistently year in and year out, regardless of the amount of rainfall. I don't think there is a strategy out there that would work. So in the permit renewal stage, I expect that to be a topic of vigorous conversation with DEP.
Great, thank you.
Evening. Hi, my name is Patrick Reffett. I'm Director of Planning and Inspections. I wanted to thank the panel for this meeting. This is a lot of really important information that I think has been the subject of a lot of unfortunate misunderstanding in the last year or so. we announced this meeting at our last planning board meeting, and one of the questions that was brought up that I'd like to have you folks respond to, I know I'd mentioned it to Tim today. During the summer ban, how is enforcement done?
So our current procedures are if there's been evidence of somebody using an automatic sprinkler system during the time when the ban is in place, we usually send a letter to the resident indicating that there's evidence that you were using a system between certain hours outside of the appropriate hours, or usually comes with a indication of what a fine. I believe it's a $50 fine for the first offense, $100 for the second offense, and third and fourth, etc. If we have had positive feedback on that, we've actually had a few of the residents call in not understanding what the ban was, or even knowing that there was a ban, and they've kindly shut down their sprinkler systems. We've also had some people that continue to use. So the way it works is I send a letter, and if it is still someone's abusing and using an automatic sprinkler, then we usually have, usually it's in the midnight hours. It's usually around 2 o'clock or so in the morning when the mandatory bans are on. And we usually have the on-call officer just go by, try to get some evidence and verify that the sprinklers are being used, and then we, like I said, I either send a letter, and then the next level would be law enforcement would go and write a citation to that owner. That's pretty much what we have as a policy in town, to try to get people to abide by the ban.
Thank you, Tim.
That's a good question.
Wells.
Wells.
Are the houses marked that they have wells or not? Because there's no limit on drawing water for wells, is that correct?
I believe the wells are included in the ban.
Thank you.
That's what I thought, too.
Nick Tenson, 169 Sagamore Street. There was a mention about the North Basin, and I'd like just to hear some amplification as to what's there, what can be used, what's can't be used, and why.
Yeah, so the North Coastal Basin, somebody asked, I'm not sure if it was Nick, somebody asked where the location was. That's pretty much anything east and north of Essex Street. That's kind of like a defining line. I don't have a map up to showcase, but it's if you think of Essex Street, anything Tobacco Road, that direction, closer to Tobacco Lake, that's all the North Coastal Basin. So we looked at, as Peter mentioned a while back, we looked at the property near Beck's Pond. Didn't come up with water that was, we had water, it just wasn't a producing well enough to satisfy the town to pump into the system. Maybe it would have been fine for a resident, single family, but not a production well, not to the quality and quantity that we needed. It actually had some iron and manganese in it as well, so if we were going to tap and use that, if it was a production well, we would have to treat it on site. So there's a significant cost there. The water just wasn't the quality and the quantity that we would like to see. Looking at the North Coastal Basin, there is, to drill a well, you need to have a certain size property. You need to have a 400-foot radius around the well.
I got your map.
Oh. So there, real quick, the right side of that dark red line is North Coastal. The left side is Ipswich.
This goes right here, all the way up.
So you can see kind of that's Essex Street as you go further up on the map. That's fairly close to Essex Street. So what I was saying before is you have to have a certain size of property, 11 acres.
Zone 1 is 11 acres.
We don't have that many properties up there that are that size, that are interested parties. There's no town property that I'm aware of. A lot of it is Manchester's watershed. So we have to be mindful of that. I believe all of that, the watershed, their source is Gravelly Pond where their treatment facility is. So there is a piece of North Coastal in Hamilton, but there's only certain specific locations that we may be able to have a production well. So that's why we haven't been drilling up there that much, just because there's not as much opportunity in that basin. We have drilled in the past. I think we did some drilling on Tobacco Beach. That didn't come back positive either. So we're always looking for sources. I mean, the North Coastal is a good supply of water. It may be something that Peter said earlier. We may look into the opportunity to tie into Manchester, if that's a viable option, a long-term solution. But drilling our own well out there and actually having it produce and pipe directly into the system, we'll have to investigate that a little further, but it doesn't seem like there's that many opportunities out there.
Can you drill a well in water? In other words, could you drill in, part of that is some of the ponds out there. Can you drill into the pond?
And then use it as a drinking water supply?
Yeah, not the well, but beyond that. I mean, not the pond, but into the ground.
I'm not sure.
I don't think that would be feasible to have like a gravel pack well there. You probably don't have the material there is not going to sustain a gravel pack well. And if you did that, then you're going to fall under surface water.
Surface water, yeah.
Treatment rule, which is a far more complicated groundwater. You would have to spend a lot more money to get that in place, the infrastructure in order to treat that and get that into the system. So it's probably not a.
Right.
I never thought about that, but.
I was just thinking of a cylinder, a pipe or something that would go down above the water line.
They have done that. They call those caisson chambers, where you can put a caisson and actually pump it into like a low-lift pump station, but you're actually treating surface water. They consider that not a well, but a surface water, and that falls under the different.
You're having an oil platform, you're having a water platform.
Yep.
Right, but again, pumping it with surface water, so they're gonna look at that as a surface water supply, so it's different.
Right?
I have a question.
But I know that. They do that for river intakes. They put like horizontal wells on the bed, but that's considered surface water. So it would have to fall into, okay, sorry.
Rosemary Kennedy, Selectman. I just have a question, two questions, but the first is the cost of digging a new well. What would that cost the town?
Well, I can go off the pilot. We did a test well over at the Ford property, and I believe that was right around $15,000.
Just for a couple of test wells?
Just for a couple test wells.
Just for test wells, not for the production wells.
Right. What about if we were digging a new well, say a new Idlewood came available?
Well,
Just-
we in our master plan, we estimated to put a new satellite well. That includes the permitting, the test well, production well. Probably, by the time you're done, probably $750,000.
750,000?
50,000, yes, I'm sorry,
Okay.
70,000, yes.
Thank you. And then my other question, and this, there might be an answer coming in the second part of this, but I'll ask it now. What is the capacity of our filtration plant, and are we near that or are we not near it?
The capacity right now of the plant, it was designed for 900 gallons per minute, which is 1.3 million gallons per day. I think right now we're pumping close to 1 MGD. I think the plant's capable of doing more on a short-term period if we need to, but I think right now the plant is it can meet the demands.
We're at about 600.
Yeah, about I think they're doing on average about 650 on a consistent basis, excuse me. But the plant can put out over 1 MGD if it needs to.
Okay.
So we haven't pumped it at that rate yet because we haven't need to do that, but it's designed for that. So
It's part of the whole picture of
Right,
looking at.
right.
Okay, thank you.
Sure.
Jeff, you want to questions in about 4 or 5 minutes?
What's that? Yeah.
Questions a few minutes? and
Yeah, why don't we do a couple more here, and then as long as everybody has their questions answered.
Alex Dale, 58 Woodbury Street. So, at what point would our population cause concern for the water we are permitted for? So,
Well, I'm sorry, as we just went over the presentation, so we estimated the demands to 2035. So based on those projections, right now the existing supply in terms of what you can withdraw will meet that demand.
so if the population's 8,500, then estimate would 16,000 be
Well, it's
the
never
maximum
Well, we
population
don't.
that the well could handle?
In 2035, the population won't be 16,000. It'll be 300 more than you have now. I think that was the estimate.
I know, I understand that, but at
He's
what
talking full
point
build-out?
would we?
Oh, at what point? Well, you can take it the population and times it by, what was it, 60 gallons per capita times 2.9
65.
people per household, and that will tell you at what point you're going to exceed the 1.3 MGD. But I haven't done that calculation, but I would say probably you start pushing probably 11, 12,000, you're probably going to be in trouble, just based on those numbers in my head. But I haven't calculated it yet. But
And can you experience a sudden failure of a well?
yes, they have. And that's why we try to keep the wells managed in a way that if we lose one, we can have one as a backup and have some redundancy in that.
And then, so if is our baseline permit 920,000 gallons a day? Right, so would the estimate for 2035 actually be skewed by 100,000 if we're no longer allowed that 110,000?
Okay, so the answer is DEP has set our baseline. Yes, you're correct, at 920,000.
So those numbers may not.
So
maybe
we don't know
100,000
whether we're going to be able to keep the 110,000. Whether, in part, it will be on how onerous the conditions look, and whether we think that that it's worth the town's while to do so. But there's still, even if you're working from 920,000, we're looking at usage in the 600s. So there's still a good margin for additional permitted volume, and that 920,000 is our grandfathered registered volume. So the chances that DEP would try to come after it seem, at least to me, to be remote.
Right, so we're safe with the 920,000 with slightly over 1 million.
Yeah, so the report that Peter was showcasing, that little piece of his the master plan, which is in draft form right now. As soon as we finalize and go through it, we'll definitely share it with the public. He's using our current withdrawal, so that's where that came from.
Okay, one more thing. Can we just get an update on the trihalomethanes and where we stand with that? Next. Okay, thank you.
Obviously, we're putting substantial stress on the Ipswich River as a source, as our sole source, or essentially our sole source. It's my understanding the legislature gave Manchester rights to Hamilton water way back when, which is why we are now their principal supply. But it's my understanding that what the legislature granted way back when was surface water only, and that they've drilled wells since. Can we get, rather than having to drill all our own wells and so forth, to try out the north coastal basin, which, if that's a good viable source and something we really need to look at, it appears, given the stress we've put on the Ipswich, can we get access to their well data if in fact they have drilled wells in the north coastal basin, in addition to the surface water, and save ourselves a few bucks and find out what the real situation is over there? Is that legally? I'm assuming, Mr. Miaris, you've looked at all of this stuff.
Well, I can't say as I've looked at their well data, but it's a public record. They have to submit what's called an annual statistical report to DEP. So it's available. It can be had, and it could be looked at. As far as the ancient statutes that created the rights in the first place, I can't say as I sit here that I recall that that the rights were limited to surface water, but it's certainly something that can be checked. There's a series of special acts, mostly around the turn of the 20th century, that allocated water rights among the various towns. It's just a matter of picking theirs out and looking at it more closely. Most of them, where it was crossing town lines, are not exclusive. That's correct. I'm sorry. I didn't refresh my memory about that particular special act before I came here tonight, but I do recall that it was not exclusive. Yes.
Yes, Dave.
Apologies for repetition. You've estimated the cost of drilling a new well for use at about $750,000.
For a satellite well, yes.
Yes.
And
Have
that-
you estimated the cost of tying in with Manchester or Salem, Beverly?
We're working on that. We haven't finalized that, but we're working on that. But it'll be more than that, for sure.
So the tie-ins will be more expensive?
Just because of the distance of the water main we have to run, it's over a mile each. So the water main alone is going to be in the $1 million range.
And those estimates will, I'm sorry.
I'm sorry, good.
Those estimates will be stated in the,
They'll be in the master plan when it's
master plan.
finalized, correct. Yes,
Thank you.
We haven't finalized that yet.
Dave Thompson, 103 Essex Street. Back in the 80s, the town started to look at the recharge areas to the town well systems. And the concern was to protect the quality of water that would come from the recharge areas into the wells. At that time, we passed a bylaw at town meeting, which was the Groundwater Protection Overlay District, which is still in place. The essence of that bylaw was to limit the density of construction that could occur within the recharge areas. There was an extensive mapping program done. There was a map, and we have a map of the overlay district. The wording in the bylaw currently says 80,000 square feet per building lot is what's required within the GPOD. That gets bastardized as soon as it gets before the planning board. And it really tees me off because it's going in the wrong direction. Basically, the concept behind the original GPOD was to limit the density of development within the recharge areas because we know they're all going to be on septic systems. So you got to keep, you know, the stuff out of the groundwater because that's going to end up going to the well. Now, one house per 80,000 square feet, that's pretty well spreads them out. Well, now the bylaw reads 80,000 square feet per building lot. Building lot is not defined in the GPOD definitions or in the bylaw definitions if you look it up. So there's a latitude taken. And an example of latitude is the Patton Ridge development. Patton Ridge is within the GPOD. There are 12 units on 4.1 acres. That's 3 units of construction, 3 houses on 1 acre. And the intent of the GPOD was 1 house per 2 acres. And I think that's wrong. I don't believe it's consistent with the will of the people that voted for this bylaw back in the 1980s. And it's not consistent with preserving the quality of water that we have to drink going to the year 2035 or whenever. Thank you.
Great. Thanks, David. All right. Thank you. Really great questions. All right, now we'll switch gears a little bit and we'll talk about the water service. Now we know where the water comes from. Let's talk a little bit how we distribute the water, clean the water, distribute it, et cetera.
Is that me again?
Yeah. So we're gonna move on, like Jeff said, to our distribution and treatment and storage. Again, we have a draft master plan that will answer a lot of these questions. It also provides long-term and short-term solutions to some of these infrastructure improvements. Also has some estimated costs associated with that for capital planning. And we're going to turn this over to Peter to go through this. Any technical questions, we do have our operator in-house with treatment questions. So feel free to ask the questions afterwards. But this is a pretty good quick rundown of how our system works. So.
Okay. Thank you, Tim. I'll keep it brief. Anybody ready for a break? 10-minute coffee break? Bathroom break? Nothing?
Maybe a stretch.
Okay, so I'll just quickly go over the facilities. A lot of this is from the master plan, and then we'll go over the plan upgrades and some of the issues that we had recently that I'm sure people want to hear about. So, anyway, so overview of the existing facilities in the water system. So as Tim mentioned, your system includes about 54 miles of water main, ranges from 4 inches to 12 inches in size, 2,500 service connections, 380 hydrants. Some of your major components is the Brownsville Reservoir, which is a 850,000 gallon storage tank, the Idlewood Water Treatment Plant, the School Street Pump Station, and then there's also a booster pump station that the town manages that serves the Gordon Conwell School as well. And, next slide. And that's just a map, the overview of the water system. I know you probably can't read it too well, but this just kind of shows where all the components are kind of laid out in the system. So we'll talk about the Idlewood Water Plant, which is the major facility that the town manages and operates. So I'll give a quick overview of how the plant came to be, some of the issues that happened to the plant over the years. I'm sure people have heard this already, but so the original plant was constructed in 2000 and was based on a certain filter media that was made by Filtronics. The plan was designed to remove iron and manganese, and as I said before, it had a rated capacity of 1.3 million gallons per day. The plant at that time used chlorine as a pre-oxidant, which is required with that type of media. And this is all from information that I gathered. I wasn't here, obviously, in 2008. But in 2008, we understand issues came up related to media loss, and there was some TTH formations in the system that were occurring that were elevated a little higher than they were in the past. So to address those issues, in 2010, the filters were converted to what they call a green sand media. Basically, just swapped out the media from the original design and replaced it with green sand. There was really no, and they also changed out the existing chlorine system with a potassium permanganate system as a pre-oxidant.
Excuse me, could you just define
Sure.
TTHM?
Oh, total trihalomethane.
Okay.
I'm sorry,
Thank you.
too fast. Total trihalomethane. Okay, so in 2010, they converted to green sand, and the thought was, with the green sand, you can use potassium permanganate as an oxidant, which doesn't produce TTHMs as much as chlorine. So that was the basis of that work in 2010. However, my understanding is that the issues with the media loss, it continued, and they also noticed that the finished water manganese levels were starting to increase to a point where the plant was really only able to operate at half its capacity. Any more than that, then the manganese removal was being hindered, and they couldn't sustain any more supply. So that was one of the issues that we were brought in to address. Next slide. So in 2017, we came aboard with Tim and Dave and the rest of the staff to evaluate the plant and see what we can do to address some of the issues with the main goal really to improve the plant capacity as well as the manganese removal, and also to mitigate any further TTHM formation. As I said before, the plant was really operating at half capacity. It was actually less than half capacity, which during the summer times, they were having a very difficult time meeting demands, keeping the tank full for fire protection. So it was a struggle. The time that I came here, that summer, that before we did the upgrades, the plant was just about ready to probably be less where we were looking at all options to bring water in. It was getting that bad. So it was a pretty dicey situation, which is why we were looking at looking at ways to really resolve the issues quickly. So we did an evaluation, and we concluded that the continued use of green sand at the plant was not feasible. It wouldn't meet the demands. It wouldn't meet the water quality required per our DEP. So we identified two options that the town could consider to address the plant issues. One was to convert the pressure filters back to the original media, because at that time the media was working in terms of iron and manganese removal, and the plant was running at its capacity. Obviously, there was TTHM issues, which we'll get to in a second. The other option was to construct a new green sand or membrane filtration facility. So, in looking at the two options and giving the need to really do something quickly, because the plant was hanging on Band-Aids really at that point, we recommended a two-phase approach. So we decided to convert the plant back to the original design, get it running to the capacity that it needs, and see if that worked and see if we can address the TTHM issue. If that didn't work, and then the next phase would be to build a new plant. At least doing that approach would buy us some time, at least have the supply so people could have water, because if the plant was shut down, there's no other source for water for the town, so it would be kind of an issue, I would think. So that seemed to make sense, and that's kind of the approach that we went. Next slide. So with that, so we did upgrades to the plant recently. So we just basically completed in April 2019. We just did the final pay rec, right, or something like that. So this is a list of some of the major upgrades that we did to the plant. So we converted the existing filters back to the Filtronics. We also replaced all the internal under drain system for the filter, and as well we also cleaned it out and we repainted them. We rehabbed 2 of the existing reaction vessels from the original design. We upgraded some of the backwash tanks and the floating decanter system in the backwash tank, both of them. We put in a new sodium hypochlorite feed system to serve the new meter in the filters. We also upgraded the SCADA system and provided a new radio communication system. So here's just a few photos of some of the work that we did at the plant. So the photo to the left is the existing filters after we drained them to inspect them. So you can see they're a little dirty, but that's to be expected with iron and manganese in the water quality, nothing unusual. And the pictures to the middle and the right show the new on the drain, the new influent drain installed, the tank all painted, all cleaned up. Next slide, Joe. And this is a shot of some of the new media that was going into one of the filters. That's the shot to the left is the on the drain media. The shot to the left is the new Filtronics media that was put in the filters. Next slide, Joe. And this is shots of the backwash tank work that was done. So the shot to the left shows that new floating decanter system that was put in. Part of the plant process that they recycled 10% of the water that's wasted back to the plant to minimize to conserve the water, also to kind of minimize the backwash disposal. So that unit kind of floats in the tank, so as it floats in, when they turn the sludge pumps on, the recycle pump, it'll draw water that's pretty clean back to the plant for treatment to try to save some water. And that's what you see in the tanks there. So the piping to the right is all new piping that we put in. That was a result of when we had the issue, we'll get to in a minute with the water quality. That was one of the piping, was one of the issues we found, that piping was faulty and basically hanging in the tank, allowing a lot of the settled filtered media in the water quality, not sludge, but the iron and manganese that was caught in the filters that were backwashed out. It was drawing it back into the plant, which was one of the issues that occurred back in November, which we'll get to in a minute. But so since completing the upgrades, as I mentioned before, the plant is pretty much running at 650 to 700 gallons a minute again, which is good. The iron and manganese have been consistently moved below the target levels. I think for the last 3-4 months it's been the same reading, which is pretty good. We also noticed that the sludge removal from the backwash tanks is required less frequently. I think in the past they were cleaning the tanks out every 2 weeks. Now it's every 4 to 6 weeks, which also saves some money because that's an operating cost that the town had to plan for. And also because of the plant was now back to its original capacity, more or less, that the town could start to flush the system again. One of the issues which kind of led to maybe the issue we're going to talk about in a second was that for the last 3 years the town really couldn't do a comprehensive flushing program for this because there wasn't enough water to do that because the plant just didn't produce enough water. So once we got the plant running, the first thing we did was just start to flush the system out. I mean, that certainly helps the water quality at the tap that you drink, and also helps meeting the water quality regulations as well. So that was some of the pluses that we got out of doing the upgrades to the plant. So now we'll talk about the issue we had, I guess. So the town, follows what they call the Stage 2 disinfection byproduct rule compliance sampling, which to monitor the total trimethylanes and also the haloacetic acids in the system. So because of the town system and the number of sources they have, they're required to sample 2 sites every 3 months or quarterly through the year. And those 2 sites, one of the sites is at 28 Goodhue Street. The other site is 305 Sagamore Street, which they refer to as the Air Force property. So the MCL, maximum containment level for TTHM is 80 parts per billion, and that's calculated as a locational running annual average over 4 consecutive quarters. So what that means, so for 28 Goodhue Street, for quarter 1, 2, 3, 4, they measure THMs, and based on this standard, they take those 4 values and divide it by 4, and if that's under 80, then they're in compliance. If it's over 80, then they need to look at what's going on. So that's kind of how the standard sets the sampling procedure. Next slide. So this is just, so you can see the 2 sampling sites. The one to the top left is the 28 Goodhue Street, and the one to the right is the Air Force property at 305 Sagamore. So these sites were determined back in stage 1, which was 2001 or 2, and these sites represent the system where the highest age in the system occurs, and these represent the highest THMs that could occur in the system. And that was a process they went through over the years. And these sites have been on their sampling schedule since like 2006 or 5. So, okay. So in November/December 2018, which coincided with their 4th quarter stage 2 disinfection byproduct rule sampling, there was an elevated THM in the system in November. And because of that spike, the locational running annual average, or the LRAA as they say, for 20 Goodhue Street was calculated to be 83 parts per billion. So it was over the MCL of 80. So once that happened, we were looking at to see what happened, what caused the spike. So in going through the plant, because at the time we were in the middle of doing the upgrades, so we thought, well, something may be going on with the plant, so let's look and see what's going on. So we did find a couple of things. One was the faulty piping in the backwash tanks, which I just mentioned. So we were in there doing some work and actually cleaning out some of the tanks, and we found out that the piping was pulling apart and allowing a lot of that settled solids to kind of go back to the plant. So we replaced all that piping, so that's all fixed and it's working. And we also, at the same time, we started using Idlewood number 2 well, which wasn't used in a while. And from previous sampling, we know that well had high levels of TOCs. And obviously TOCs with chlorine does produce TTHM. So we thought maybe that well, using that well at that time also contributed to that spike. So we took that well offline, and it's been offline since. So next slide. So in addition to that, we also began a routine flushing of the system, mostly in the area that where the THM spike occurred, to try to address the water age and get the water as clean as possible. We also began to sample monthly instead of quarterly, so we could measure the impact of what we're doing to see, is it working? If it's not working, what else do we need to do? And we also began to sample the THMs at the plant, just to see what's coming at the plant, to make sure that we're doing the right, that what we're doing was effective in terms of reducing the THMs. So the results of the monthly sampling was good. It was showing that we reduced the THMs from the spike that occurred in November. The monthly sampling from December to May, the THMs ranged from 61 to 74, so they were below the 80. Recent THMs in June were actually 52, was the best we got to date. And I think that's a result of keeping the Idlewood well 2 offline, and also the water department's been flushing Highland Street at the end of the system as much as possible to keep the water age at a reasonable timeline, and also keep the system clean. And that's been working, well, to date anyway. So, however, because the way you calculate the TTHMs, it's on a locational running average. In 2019, the first quarter sampling, even though the previous months the THMs were going down, you still carried that spike into the equation. So we had another violation, not that we had an issue in the system like we had in November, but because that issue was carried through. So and then I think at that point, the town, we did put out a public notice, which is required per the rule, to explain what was going on. Next slide. So, since then, we've been sampling every month, and we've been sending reports to DEP as part of their requirement. So they have this information. So as I said, with the June results, we got a 52 parts per billion. So based on our calculations as of right now, which is unofficial because DEP hasn't really given us any feedback on the recent sampling, but right now we calculate the LRAA to be 79, so we should be back in compliance as of June. And the table to the right just shows the sampling the results of sampling that we've been doing since the November. So in November, we had a spike of 120, and the finished water, THM was 90, which was the result of the piping and the use of the well. And then we made those corrections to that, and then every month since we sampled, we got 61, 74, 64, 65. So we've been below the 80, so which is good. And the finished water TTHM has also been low. And we just did a quick calculation on the bottom to show that as of right now, we should be back. The town should be back in compliance. So we're gonna be continuing to do the monthly sampling. They're continuing with the flushing. We obviously have some long-term solutions to look at. As I said before in the previous presentation, we're looking at putting in a TOC removal system at the plant, aerating the clear well to help reduce the THMs. So we haven't finalized exactly what we're going to do yet because everything has a cost. So we're going to look at what's the best solution for the town to proceed. But for now, we're going to continue with keeping Idlewood Well offline and doing the flushing and monitoring monthly to make sure that what we're doing keeps the water quality within the standards, right? And just to put things into perspective, I know people are concerned, and rightly so, they should be. We put together this table of other communities around Massachusetts, what their annual THMs are and what they deal with. It's not just an issue at Hamilton. I mean, a lot of towns are dealing with the same challenges that Hamilton is. So this is a quick rundown of some towns and cities and what they're dealing with. So you can see that THM ranges are, they go from as low as 19 to as high as 79, and last year the town of Milton had an exceedance as well. Even Salem Beverly, which has a very sophisticated treatment plant system, also had a high of 124. So it's not uncommon to have these spikes, but as long as the next quarter you get it down and you put those actions in place. So anyway, with that, we'll also take any questions on. Yes.
Fines when you're out of compliance?
You get fined if you're out of compliance and you don't follow what DEP then mandates you to do, and if you're not doing your due diligence at some point, if you continue to go out of compliance, they will fine you, yes, at some point. I know exactly what the violation requirements are for that, but because once you go on a violation, then you need to notify, and there's certain standards you need to follow, and DEP is involved, you have to coordinate with them. And as long as you're doing your due diligence and working in the best faith and trying to, address the issue, they work with you. But if you don't work with them, obviously, there's an issue with that.
Dave Thompson, 103 Essex. Just two simple questions. Let's assume we want to give up on Idlewild 2 well.
Mm-hmm.
Did I hear you say we could get a permit for a replacement well as a satellite well or something
Correct.
Like that?
Yes.
Yes.
Yes, we can, yes.
Okay, so if you want to give up on that because
Right.
it's not good quality water and whatever, we can replace that at that location.
Correct.
Okay.
Correct.
Second question is, assume the treatment plant evaporates. It no longer works, something went wrong. Do we have access to water through connections in Manchester, Beverly, or others that would service the town while we totally destroyed this thing and replaced it with a new one?
I'll answer, you can answer that. So question is yes or no. But the town has interconnections with Essex, Wenham, and Ipswich, I believe, but not enough to really replace the loss of the plant. I think they're probably 100 gallons a minute. Mm-hmm. Some maybe less. We don't have anything with Salem Beverly, my understanding right now. We're looking into possibly doing that, or with the Manchester right now either. Again, we're looking at those two options to see if that connection is worthwhile for the future, where the plant may need to be shut down for a few major maintenance. We have a source of supply, but right now we don't. I don't think we have enough to really sustain taking that, which is one of the reasons why we decided to upgrade the plant, because to build a new plant, there's no place to put it except where the plant is now. So we couldn't take the plant offline because we don't have enough water to really supplement that for a year and a half construction. So that was some of the challenges we were faced. Well, how do we deal with this while keeping the water coming into the pipes, you know, so. Take the next one, Ty.
Have we ever determined who actually owns the property where the well fields are?
The Idlewood well fields?
The actual property where our wells are. It was unknown back in the 90s. I know that, and I'm just wondering whether we ever got the fee on it straight.
Yeah, I don't. That's a good question.
It's a good question. Yeah, I guess I've been under the impression the town owned them. I know we do have. There is an Audubon. We have an agreement with them as part of the piece of that is being Audubon property or under their direction or jurisdiction and care. We meet annually out there just to go through the property and make sure that everything's in compliance with them. So there could be some kind of joint ownership there. Yeah.
At the time, Bill Shields was town council when we drilled our fourth well over there, and it was determined that Audubon's property line came up to the edge of the swamp. And since most of those wells are on the high ground beyond the swamp line, there was a question of who actually owned that property. I guess it's never been. Do we know whether it's ever been straightened out?
It's town property.
I assume you're on the zone 1, right?
Yeah.
Dogs love
Yeah.
it. Exactly.
Yes.
I have one curiosity question, it's a personal question that I heard or read years ago, and it could be totally false information, but that Beverly, because they have this massive water tower at the top of a hill, that they are able to take, I don't know how much, but a lot of water out of the Ipswich River, and to the extent that they have so much water that they don't have water bans, but I worry that they're taking more than their fair share, which is hindering the smaller surrounding towns that don't have the money to put up a huge water towers. Any of that true?
I honestly don't know, but do you?
I'm not sure.
Well, Ray, correct me if I'm wrong, there are 2 watersheds in the state that are overgrown and over permitting.
Yep.
So Ipswich River is one of them. Beverly and the Beverly-Salem Water District do have rights to water in the Ipswich River watershed. I'm not aware of the exact amount of draw that they have, but they even own the rights to, they or Danvers even owns the rights to the water in the Wenham Lake. So obviously, when Ray referred to all the special act machinations back at the beginning of the 20th century and all these towns trading where the water rights were going to go, Beverly and
Because they
Salem
only
and
have a
Danvers
registration.
had good
They don't have a
representation
permit.
because they got lots of rights to water that weren't even in their town line.
Is that
But,
true?
I don't think they have a permit.
that's one of the concerns for anybody in the Ipswich River, that so many communities are served by it. And the towns that are further upstream, do create a crisis for us. At the same time, that's one of the reasons to open a conversation with Beverly-Salem to see if we can make an interconnection with them through Wenham. So we're going to look at that, and we'll try to start that conversation with those folks and see if that's a way to increase our water security.
All right, thank you very much.
So a part of the answer also is that they don't have a permit. They only are operating under their grandfathered registration rights, and water bans are a creature of DEP's permits system. So if you don't have a permit, you don't have to have a water ban. And that's the legal answer about that. As far as how much water do they have, many towns are experiencing that just modern plumbing fixtures, are more efficient than the old ones, and just like we have extra room under our registration volume, they probably do as well.
All right. I just, going forward, 50 years, 100 years, it just makes me worried that they're grandfathered in some way that really hurts the small towns.
Undoubtedly, they are grandfathered in. I'll leave it to others to judge whether that's helpful or harmful.
All right, thank you.
Yeah.
So I have another. Can I?
Yeah.
I have another comment about water system. So I have a copy of our 2018 annual drinking water quality report. It was published in the Chronicle in May of this year. And being a nurse, I noticed that we have a very high sodium level. And I know, Tim, I've chatted with you a little bit about this. One of the concerns, it looks to me that our sodium level is allowable at 20 MCLs, and, or not ours, but the ideal goal is 20 MCLs, and ours is close to 100, 98.5. And so that certainly impacts people who have health issues, because sodium, of course, can contribute to congestive heart failure, high blood pressure, all of these very legitimate concerns. And so when I look at this, that the possible causes of contamination are discharge from the use of de-icing compounds that we use in our streets, and also water softening agents. So I'm sure this conversation will continue at some other time, but I, as a selectman, have concerns about using the type of de-icing compound that we have, and I'm hoping that we can have more of a conversation about changing it to something that's less harmful to our water supply.
Thank you.
It's just a comment.
Sure.
that I'm aware of it, and in the best interest of the town, I would like us to do something to improve that situation.
Thanks, Rosie. Bill?
Bill Bowler, Essex Street. Certainly, Jack Audubon believes that they own the land that our plant sits on, and I think that's been the assumption of the town. I think under the agreement, I haven't seen the map, but under the agreement that was entered into with the selectmen when they granted us a license to put the plant there, the town agreed to turn over certain parcels that it got title to under tax taking. So I think it's pretty settled that the plant sits on land owned by Audubon. And certainly when I was a selectman and we approached them to about putting a cell tower on the top of the plant, they just flat said no. So they assumed that they owned it.
Thanks, Bill.
I think there's some agreement. That's what I was trying to say.
Hello, my name is Virginia Cookson, 318 Forest Street. Just curious, we have a reservoir that's underground on top of Browns Hill, right? And we wouldn't have enough water to have a downtime on our plant for a really good overhaul it might need for a few days. So is there any thought, or does anyone have any idea as to whether there's one or more other places in town that even small reservoirs could be put, and you have 1 million gallons in each one of them, which would give us a couple of days downtime?
Sure, I'll answer that. So as part of the draft master plan, we did evaluate the system storage, and we did evaluate other potential sites for storage tank. And I think in the master plan, we did identify the Silly Hill site, right, as a potential site, because it's right off Bay Road, and it's right where the high demand for fire flow is, so it would be a good spot to put a storage tank. However, to answer your question about having additional storage, because of the water age the issue already in the system, obviously the more storage you have, the more potential issue may have with water age, and it may lead to more water quality issues like we had last year. So you need to balance, and that's the issue. You need to balance the storage you need for public safety, for fire protection, and for redundancy for plant work with, can you move the water? Can the water be mixed? So what we recommended in the master plan, and it has, that is going to under review by the board of selectmen right now, is that to build 2 smaller tanks, one at the Browns Hill site, and one at the Silly Hill site, both like 0.65 million gallons, excuse me. So the total would be a little bit more than you have now, but the tanks would be provided with mixes to turn over the water to keep the age, where it needs to be and have adequate turnover, and also to put the storage in better locations so the system would be more effective for you. in terms of
What would be the total?
like 1.2 million gallons, maybe 1.1. We start going more than that, then we get issues with water age, so we have to kind of balance that.
Unit or?
Oh, total, each tank would be 0.6.
Okay, so that would not help you with the shutdown for you?
Well, you would have a little bit more with 2 tanks running, and you could probably, have better fire protection, so you couldn't go for days. I mean, you're talking a couple of days. But if you had to do a major construction project where, like, for example, what we did took, what did it take? 8 months by the time we were done? But we were able to do that with the plant running, so we did one filter at a time. So if you had to shut down the whole plant or build a new plant, just shut it down, you wouldn't need a connection like Joe had mentioned with another town or something, but.
All right, great questions again. Thank you all. We talked about the master plan being finalized, and that'll be posted on our website. Any other next steps that we foresee kind of in the immediate future that people should know about?
I could offer a quick update.
Yeah.
We've talked a lot about investigating the sources with Manchester or a well site potentially in Hamilton in the North Coastal. We're actively looking into those things. I have a meeting with the town administrator in Manchester on August 7th to sit down and talk about what might be necessary to try to come to some sort of agreement if we decide we want to go out that way. He has previously expressed some interest in that, but obviously there's a lot of talk that still needs to happen, a lot of negotiation. They have a level 4 treatment plant, and we have a level 2 treatment plant because they take their sources as a surface water site, and we get ours from wells. So we have to figure out if it's worth it for us to go out and tap into a surface water site or not, and what the cost of that would be. As Peter indicated, the cost of that would start with running pipe down Chabaco Road to the plant, and that's over a mile away, so that's going to be at least $1 million for the pipe, not to mention any other things that come up with that process. So all of these solutions have, all these possible solutions, I should say, have costs, and we're trying to balance what the benefit of the solution is versus the cost to the town, the ratepayer. So all of this gets paid for in your water bill. So we're trying to be very cognizant of that. I also want to mention the town did approve at town meeting in April a pre-treatment for the TTHMs. We have not embarked on that project yet, but we will. We're trying, as I said, as you saw today, there's a lot of different parts moving, and we've been able to control the TTHMs in the water since the start of the year. And the question becomes, is it fiscally responsible to add the pretreatment if we wind up going in a different direction for our water sources? So I think is it fiscally responsible to do that if there's other things that the system needs, like better reservoir tanks? So we're trying to, the master plan is going to help us answer some of those questions. Our discussions with Beverly and Salem and Manchester will help answer some of those other questions, and then the Board of Selectmen and Water Department will bring other options to town meeting in the future, and to the FinCom and everybody else in between. We're working on it. The good news is you have safe drinking water right now, and the town's doing the best it can to ensure that into the future and to ensure sustainability of our water sources into the future. So.
Thanks, Joe. And thank you, Peter, very much. Thank you, Tim. Thank you, Ray, for all this information. Thanks for the great questions, everybody, and have a good night.
Thank you for coming.
Thank you for coming.